like project pack, you know.
Exactly, 3 to 6 months.
Yeah.
Look at you, girl. 89.
They raised me, honey.
That's fun.
You right on it though.
All right, so let me give you another example.
Okay.
We'll extend it a little bit.
Are you gonna pass out our homework while you do the example?
I was gonna wait till the homework after I do all the.
Okay, gotcha.
all the
Because sometimes it's like good, whatever you fill the paper, see the example, work with you, but we don't have to fill them in. What do you think about it?
Why don't you wait a little bit, because
Okay.
the last question on the homework will be material we have not yet covered.
Yes, sir.
No, it's not. But there's some news in the COVID.
All right, so I'm gonna put up some numbers.
Okay. Oh, we're doing a whole new.
We're gonna whole different thing with the linear graph.
Okay.
Do we need this? I mean, is this something that's gonna be
Yeah.
that, as far as?
Now, these examples, I'm not doing as many data points.
Gotcha.
Okay, cool.
But just kind of.
Same type
Yes,
of.
sir.
That's a lot.
All right, so let's say. Let's do 5 data points. I need that. Yeah. All right, so what these numbers are supposed to represent is across some arbitrary made-up numbers. On the left, X here will represent the number of hours a particular student studies for material. Okay, so 5 hours, 8 hours, 10 hours, 5 hours, 3 hours. On the right, let's say that represents the score they get on the next exam. Okay.
They should all study 5 hours.
I feel bad for the person that studied 10 and still didn't get 100.
But they study 5 too and got 60.
Yeah, dang.
People are variable. Right, that's the whole point. Not everyone will fall exactly on a straight line.
Right.
All right, so the question is, what is the line of best fit that predicts your grade on a test from the number of hours you study? All right, let's say per week. So here we'll say number of hours per week. Okay.
Wait, so what is the line best fit for?
Predicting the score on an exam, which is the Y value here, from the number of hours you study in a week. Right? As before, let's rearrange the columns a little bit. So there's my table. All right? X squared, Y squared, XY. Okay? As always, you will need summation for these terms. Oops, that's wrong. I'll start the easy one there. 31. $350.
2330.
Check this one too, I think I have 26,400. The other three numbers leave away.
26 That's fine.
Okay. Use calculators.
How are you getting that N number, that 450 inside?
X, Y, X times Y, 5 times 90.
Okay, I see now.
8 times 70, 560. 10 times 90, 900.
Okay,
300. Next one.
got you.
Okay.
Why is that backwards? Like, oh, it don't matter how it goes?
What do you mean?
Oh, because it was X and then X2, Y, then Y2.
Yeah, it doesn't
Then
The
matter.
order of the columns makes no difference.
It don't matter?
Doesn't
Okay.
make any difference whatsoever.
Gotcha.
I did that on purpose, actually, to show it.
Honey, I'm just slightly dyslexic anyways, so that, those things right there, that just contribute to the LD.
So if I want to find score for test or an exam, predicted from number of hours of study, right? I'm predicting Y from X. That's the equation you're using. And you're going to plug in the values. So values plug in there. I see if I'm plugging the values.
Okay.
Quick question, will we need to, would you have these columns for us like this, how you did it on the first exam, or will we need to know X, X2, Y, Y2, X, Y?
It varies. On the homework, instead of columns, I got rows. On the exam, I may set it up as columns, I may set it up as rows.
But you'll have these for us to.
For
okay.
one of the problems on the exam,
Mhm.
I'll probably create the table for you.
Okay.
For the linear regression, I'm gonna want you to create the table. But recreating the table over and over again, squaring a bunch of values, summing all the values, I wanna know that you can do that, right? But once you can do it, it's redundant to have to do it 3 and 4 and 5 times, because it takes up a lot of time, right? That you can spend better working the problem itself. Okay. $215, is that right?
No?
Here. Oh, wait. Sorry. 2,107. There.
I got 7.
Hmm?
I got 2,107.
No, I think 2,107.
I got
Yeah,
7.
no.
I got 7.
Wait, yeah. Give me one.
So I'm not being dyslexic.
Yeah.
$961 divided by 5.
192.2.
192.2. I'll say 5.2. Let's just round it off. That's my slope. Once I have my slope, notice when you're doing linear regression, start with the slope. Okay? Go back over here to my equation for the line. I want to choose the best representative for my x and my y times show my means, right? .2 for x bar, right? And for y, 70. Plugging in values. Yeah, that matters, I did. 41.4. All right. Now I can plug in that, my A term, my line of best fit, and the full equation for the line of best fit.
How many problems are gonna be on the exams that includes this area?
Can't say. You'll probably do one
Approximately.
one big linear regression equation,
Yeah.
but you'll probably have to calculate a number of predictions from it.
Okay, is there gonna be questions like there was last time in the beginning, like those multiple choice
Yes.
questions?
Yeah.
How is that possible, cause there's nothing to ask?
Oh yes, there is.
There ain't nothing to really ask.
Everyone. we'll
Dr.
get this.
Prather?
Every one of these types of equations has built-in assumptions behind it.
I got you.
In the math.
I figured as much.
Right.
Well, now it makes sense, I'm thinking about it.
And there will be a little more coming up here in the next 20 minutes.
Okay, gotcha.
Right. So
Wait a minute. So we write it as y equals 5.2 x.
5.2 is the slope. X is just a variable x, and y is a pair of scores. 37.76 is the y-intercept.
You see it?
I do see it, okay, and that's the answer, so if we just give you A equals 37.76, you're gonna be like, what is that?
If I ask for an intercept, you're correct. If I ask for a line of best fit and you just give me 37, you're wrong.
She
A
gets a
single
little bit of
number.
points though, don't she?
A single number is not a line of best
She gets a
fit.
little credit though for attempt.
If you get part of the equation, you get part of the credit.
Got you.
So.
There are two numbers that have to go into the line of best fit, the slope and the
Yes,
intercept.
you gotta circle it.
Right, so I got a couple
Where
of
you
questions
talking about?
using that line. Right?
Is that the
What
answer?
score do you
Yeah.
predict somebody getting who studies 0 hours in the week?
Your answers.
If you don't study at all,
Yes.
what score do you predict the person getting?
C minus.
0.
If you study 0 hours,
So would you do
What is the score you
5.2
predict?
times 0 plus
Ah.
37?
because that's the intercept.
Yep,
Makes sense.
Right.
he's right.
So if x equals 0, y will equal 37.76. Make sense?
So he got points for putting his name there?
37.
Here's another question, right? Let me do a quick set of math in my head real fast. What score would you predict somebody to get if they study 15 hours during the week? Yeah. You study 15 hours a week, what score do you get predict the person getting on the exam?
It's not what I'm doing.
Might be.
I don't think so.
115.
That's still what I got. Like, is that possible?
No.
Over
Is that possible?
No, unless you got an extra credit.
Yeah, unless they have extra credit.
Necessarily. Because it's 100%.
Did I say anything about extra credit at all?
No.
Exactly, so how is that
Exactly, we
possible?
don't know.
Yeah, we have extra credit on that.
So how is it, here's the question, how is it possible the 15 gives me a score higher than 100%?
Because it's out of the range of the graph. I don't know.
Yes. The
mean,
line-
yeah, technically, you can only get 100 on a test, but there's always. You can
That's
get
very
100
close. That is very close, but actually it's not correct.
Okay, tell us.
Do tell.
What is the primary assumption you are making about this?
That is a straight line.
Okay. What is the relationship between these two sets of variables?
They're not.
They're not straight. They're curvilinear. Right? In other words, the actual graph representing number of hours, we'll say percentage on your test, goes like this. Right?
Mm-hmm.
And it maxes out, it's asymptotic, at the top. So at some point, regardless of how many hours you study, you're still not going to get higher than 100%.
Right.
Right? This is a curvilinear set of relationships. That assumes a straight line.
Okay.
Oh.
Right? So that is assuming the line goes like this as the line of best fit.
Okay.
And it doesn't. Right? You're assuming a straight line when a better representation of the data might be curvilinear. Does that make sense? Not going to test you over this specifically. If I wanted to have a better representation of a curvilinear relationship, what would the equation look like?
A better representation.
See, remember some basic algebra stuff. If I were to draw a graph, I want to say my coordinate system, right, that looks like that. Remember what that was called?
Parabola.
It's a parabola. What do I have to have in order to have an equation for a parabola? I would call this as y equals
Okay.
Yeah.
some, I'll put a C there. One of your terms has to be an exponent squared. And that represents a single curve, right? That x squared, determine whether C is positive or negative. So that could be this, that could be this, that could be this, that could be this. You know, any single straight curve is represented by that. If I wanted to have data, if I wanted to represent data, let me get rid of this stuff again. On my coordinate system, where the graph looked like that, right? As a curvilinear relationship. The equation would look something like that. Now I have the third exponent to the third power to represent the double shift in the curve, right?
And B and C just represents any variable.
Any constant multiplied by that, yeah.
Okay.
So you know, the D and the C kind of terms would represent whether it looks like that or whether it looks like this,
Okay.
right? Whether it's spread out or whether it's really narrow, right? Those terms would specify the exact characteristics of the curves, right? But in order to have a curve that flips both directions, you have to have an exponent to the third power, right? Similar kind of thing. Suppose, in addition to having a number of hours studied, right, I've also got how much sleep the person got in the week. So that's some term here. Where the same person gave me 5 hours of study. Let's say during the week they got 28 hours of sleep. 28 hours of sleep, right? Roughly.
In the week.
Yeah. Well, that would be roughly 4 hours per night,
That's awful.
right?
3 hours.
Right,
20 hours of sleep.
You should put that down on the 60 score.
If the person got 7 hours of sleep per night, and 35 for the week, right? If I had a z-score and a y-score, and a z-score and an x-score, trying to predict a y-score, the more data I've got about the person's life, the better my prediction will get, right? Notice if I know, for example, how many hours you studied, how much sleep you got, how much exercise you got that week, how much social contact, how many beers did you drink that week, right? How much methamphetamine did you shoot up?
Oh.
Well, that'll be negative, right? That'll bring the numbers down because the number can be positive or negative. Hours of study, grades go up. Methamphetamine use, grades go down.
Absolutely.
Huh?
I was gonna say
The
that.
methamphetamine use doesn't mean that it doesn't cause you to go down,
Correlate.
It's correlating.
Mathematically, correlationally, the linear regression
Yeah, yeah.
will give you predictive power.
But it doesn't mean that's the sole reason. So maybe
It's not
maybe
causal.
Maybe it's just
It is
the same.
predictive. It's not causal, it is predictive. My point is this: if I'm trying to predict a y-score, and I know some characteristic of x, and I know some characteristic of z, and I know some characteristic of w, right? Plus some here. The more terms I know, the better and more accurate that prediction becomes.
But you said, this isn't gonna be on the test.
Conceptually, I want you to write it in the area of science. Right? If you want to make better and better predictions,
Know more about the
mathematically,
person.
you can add more and more variables to the equation.
Okay.
And the more variables you know, the better your prediction will come.
And how would you know
If I know
about
the person's age, if I know their socioeconomic status, if I know their high school education, their background GPA in high school, right? That gives me more and more variables. I can make better and better predictions of what their grade should be.
That's crazy. And you would just add them all up.
Yep.
You would just
You
add
mathematically,
them.
well, notice when you say add, some of them will add in a negative direction because the constant in front of it will be
Yes.
negative,
Alright.
like their heroin use.
Right.
That makes, okay. So
Right.
it may, okay, now.
And then you can couple this kind of thing with other terms, like the x squared term, you might have a z squared term, right? You get a whole bunch of, this becomes what is called a multiple regression.
Okay.
Short version is, the more variables you know, right, the more information you know, the more and more accurate your prediction can become mathematically.
Gotcha.
Right? For our purposes, we're gonna assume everything's linear. Linear and a straight line, right? Which makes it simplified down to stuff like this. So I'm gonna ask one more question on this before I move on. So assume number of hours studied, grade represented there, right?
Okay, that little, area that you have to the left of the board is something that we're gonna be using, right?
Well, just for the
The
purpose.
little z, no.
Oh, for the purposes of this? Oh, gotcha.
Oh, okay.
I was simply saying that's another variable, you can add more
I see,
information,
I
make
see.
more and more accurate predictions.
Got you. Okay, and so then the other area, we're gonna use, okay, I got it in order now.
Alright, so here's the next question.
That's for that master's program, I need to do research.
I just love
What
wrong.
grade, what grade would you predict for someone who studies 60 minutes a day?
89%. Are
Based
you
on this
asking-
formula.
Oh, I thought you were asking. Me a question. I'm like 89.
Assume this particular linear regression is a line of best fit
Okay,
predicting
gotcha.
grade from study time, right?
Assuming like Sunday through, 7 days a week.
Yeah.
Yeah, 9 to
That's
5.
part of the question,
Yeah.
right?
Mhm.
What grade do you predict from somebody who studies 60 minutes a day?
60 minutes a day.
You said 60
Okay.
minutes a day, right?
Well, I did say 60 minutes a day.
Okay, so these are,
It's 7 hours a week.
So it's 74 kilovolts.
That's
better.
better. Yeah, that's what you recognize your statement, right?
That's what I got my math from,
I put it in 60 first,
There you go.
7 hours.
Here's the mistake people frequently make,
Use
right?
minutes instead of hours.
Don't get into the habit of simply plugging in numbers based on rote, right? If I say, what is the grade you predict from somebody who gets 6 hours a week? You calculate 6 times 5.2 and add that. Say, what's the grade you predict from somebody who gets 15 hours a week? And you plug in the X and start. I say, what's the number you get with 60 minutes per week? You plug in a 60, you made a mistake. Because 60 minutes per day is 1 hour per day, which is 7 hours per week. So the correct number to plug in here is 7 for X. Not 60, not 1. Right?
Right.
Watch your units. Right? Watch what the material comes from in terms of what are the raw score data originally deriving from. Right? And then recognize that sometimes you may get numbers potentially out of range if you violate linearity assumptions. Does that make sense? Question on linear regression. We've got about 30 minutes left. I'm going to do another one big set of questions. Not have time to do two. Let me move this slightly. So I'll put it up here in the corner. Get rid of this. All right, so linear regression equations are essentially calculated as line of best fit using your original raw data, right? The raw data X, the raw data Y, number of hours per week, score for exam, raw data, okay? Conceptually, right? I can take those scores, treat like we did before, a week ago. This is a set of X scores, right? The series of X scores has a mean of 6.2, right? I could ask, what percentage of the population, if this is representative of the population as a whole, this particular sample, what percentage of people study more than 8 hours a week, right? Goes back to the previous step we started with, and I can turn these values, essentially as representative, into Z-scores, right? And calculate percentage above and below and between, assuming this is one set of scores, right? But I can also calculate Z-scores for my grades, right? So for example, I can have a Z-score for my X values and a Z-score for my Y values, right? Where I convert the 5 to a Z-score. I convert the 8 to a Z-score, right? I'm not going to do this, but conceptually you could, right? The 5 would be a negative Z-score because it's below 6.2. The 10 would be a positive Z-score because it's above the 6.2, right? Now, if I drew a Z distribution, the 6.2 is there, the 5 is there, the 8's there, the 10's there, and the 3's down here, right? And every one of those values corresponds to a particular Z-score, right? I can do the same thing for the Y-scores. I can have a Z distribution where the average is a 70, right? Somewhere up here there's a 90, somewhere here there's an 80, somewhere down here there's a 60, somewhere down here there's a 50, right? And I can convert essentially these scores into Z-scores as well, right? Does that make sense?
Yes.
So I get a series of Z scores for X and Y. I can then take my Z scores and square them, just do this sign kind of stuff, right? I can create squared Z scores, and I can have a column, I'll draw up top here, a Z score for X times Y, where I multiply the Z of X times the Z of Y for the score, and I can create a line of best fit for the Z scores. Does that make sense? We're not going to do this. Conceptually, does that make sense?
Okay.
Well, we are and we aren't.
Okay.
Right?
You've
We're
already
not
done
going
it.
to do it that way.
Okay.
Right? I want conceptually, do you understand? I can convert every raw score into Z scores. I can use those Z scores and treat them as if they're raw data and calculate a line of best fit for Z scores. Okay? What's the mean? What's the paired mean for the Z scores? Paired set of scores for Z scores. If I have Z sub X and a Z sub Y, what's the mean? If I have a Z score here and a Z score here, what is that value at the center?
0.
0 for both,
Yes.
right? So if I have a line of best fit where I use the means, which is Z score zeros, to calculate my best fit, what does the intercept term equal? No.
Or it's the answer. I know what you
It is the intercept, it's the origin point, it's 0, right? In other words, there is no intercept, well there is an intercept, but it's 0,
Okay.
right? If I'm using the means for the Z scores, right? So effectively here, if I'm doing a linear regression on Z scores, there is no intercept term, right? Effectively saying, we'll say, well, I'll rewrite it slightly. It's effectively saying Z sub Y equals some value times Z sub X plus 0. And that term drops off the equation. And what I'm looking at is, what is this term? Which is effectively, not exactly, it's effectively going to be the slope of Z scores. Right? That make sense?
Mm-hmm. It's coming along.
All right. That value then, the effective slope
Yeah.
of Z scores is a correlation
It all
coefficient.
works out.
This is called correlation coefficient. So we're going to score for correlation coefficient.
Okay, so just to re-evaluate, this area and what we have our homework and what we had just turned in is gonna be our exam.
The exam is going to cover Z-score calculation,
Okay,
linear regression,
got you.
correlation coefficients, which is what we'll do right now. Correlation coefficients is one step further on the left.
That's a little bit gonna be a
It's
little
one equation.
hard.
It's one equation, right?
Okay,
It's effectively calculating the slope of the Z-scores.
okay,
Right.
so
So here's my slope for my linear regression,
on it.
right?
That's just the slope.
That's just the slope, right? There's not going to be an intercept term because the intercept term drops to 0.
Okay.
So we're going to have one number here representing the degree of association between two sets of scores, right? whenever I put up an equation, I always feel like I have to say, don't freak out.
I like that disclaimer.
Are you about to say that now?
Yeah.
I just
Say
said
it, don't freak out.
Famous last words.
I was about to say it.
There's the numerator. That numerator should make sense because that numerator is exactly the same thing as the numerator for the slope of my linear regression equation. It's the exact same numerator. Right? Those things are exact.
What does R mean? I'm so sorry.
R is the Pearson product moment correlation coefficient. It's represented by the statistic R. Right? So instead of a B,
Okay.
it's an R.
Gotcha.
Almost always represented as a lowercase r. Although I have seen it rarely represented as a capital R. But those people didn't know what they were doing. Okay. It's almost always represented as lowercase r.
And I don't even know what you said. What did you say that it represents? The
R.
It's for
Thank you.
correlation.
I couldn't even write that down. I don't know. Thank you.
Basically, it just means that that's the letter that means.
It's
correlation.
represented by R.
Thanks.
It's called a Pearson product moment correlation coefficient.
Pearson, the man that writes the books, huh?
Mm-hmm.
No.
Ah.
Pearson is the name of a publishing company. I have no idea, and I suspect not. Pearson Publishing Company is not the same person as Pearson who did the statistics.
Okay.
Okay.
He had nothing to do with publishing companies, as far as I know. If he did, that would be a really neat little connection I was previously unaware of. But I suspect it's an entirely different Pearson.
Just look it up.
I've looked up Carl Pearson quite a bit, and I've never
Okay.
seen him
Well, then that
involved in
sounds
any
great. Yeah,
publication.
then it probably is not.
It's probably not.
You know.
Yeah, you know.
Well, I don't know the history of the Pearson Publishing Corporation. My suspicion is they did not even come into existence as a corporation until probably the 1960s or 70s. Carl Pearson died in the early 1900s.
Oh,
He did
wow.
he did most of his work this area around 1919.
Stress.
Dr. Prather, what's your favorite thing to eat?
Crickets.
What? Squirrels?
Yeah, correct.
Where does that come from?
I was just wondering, what do you like? I'm getting hungry, it's why.
Blueberries.
Honey, I got a buffalo chicken wrap from Chick-fil-A waiting on me.
That's why you're so smart. You eat blueberries and crickets.
Tell us what you eat. I want to know a little tidbit or something.
So we can
I don't
calculate
have
your
a,
Z
I have a
score.
variety of things.
You
Anyway.
eat healthy.
Denominator for the equation. Notice the denominator here is the summation of x minus summation of x quantity squared over n. That is part of the denominator for the Pearson.
Part of it.
The exact same piece here is the sum of squares shows up as part of the denominator for the Pearson product.
Parts.
Oh, part, right.
Part. Notice I'm leaving some space here.
Mm-hmm.
A lot.
Okay. That so far looks identical, right?
Yeah.
But now, keep in mind, I'm doing a measure association between two sets of scores. This slope predicts y from x, right? The Pearson product works both ways, right? Y predicts x, x predicts y. It's basically symmetrical in terms of the interpretation of predictive power, right? So I need to have y in the denominator here. I need a sum of squares for y.
No fruit.
Which looks like that. Notice everywhere there's an x here, I put a y here.
Okay.
Right? And this is a sum of squares for y. Notice also, that's now going to use every single term over here in my original table where previously the slope didn't use the y squared term. Now we will.
Got you.
R. Okay, got
Right.
it. It's for R.
One more thing in the equation.
Just one more?
Just one more.
It's not very.
If I have a sum of squares here, and I multiply by a sum of squares here, right? I've essentially multiplied two terms, one times the basis, kind of like a squared sum of squares. I need to take that back down to the original units.
Oh.
So I have to have a square root over everything in the denominator. That radical sign covers everything in the denominator.
All right. I know I'm gonna predict that.
I will give you this equation on the exam.
Well, yeah. Yeah.
How will we know if we're looking for R or B? What would be like?
B is a slope, B is part of a linear regression, R is a correlation coefficient.
And
Okay.
it's gonna say that in the question.
The question will be something along the lines of, what is the degree of association between these two variables?
What? Now say what?
Earlier in the class, we talked about measures of central tendency. What were the measures of central tendency? What were the measures of central tension?
I don't know what you mean.
Mean, median,
Oh,
I was
okay.
gonna say that, but I didn't want to.
What were our measures of dispersion?
That's for like range and stuff.
Range is one. What were the others?
Mean, I don't know.
Range.
That's central.
Standard deviated.
Standard
Okay.
deviation, variance,
Oh,
There, okay.
right? Potentially things like interquartiles. We didn't do that,
okay.
right? We then talked about measures of association, where I have two sets of terms. I'm looking at how related they are to each other. One measure of association is a calculation of a linear regression. Another measure of association, right, is correlation coefficient, right? There are multiple different types of correlation coefficients. If, for example, rather than saying, what's the linear regression predicting score on an exam from number of hours, I simply said, what is the measurement of association between number of hours studied per week and score on the exam? You plug everything into this, you essentially plug in the exact same numbers, 2330 minus, in the numerator then, the 31 times the 350 divided by 5 divided by summation of x squared is way over there. It's 223 minus the 31 squared over 5 times the 350. Oops, that's wrong. Sorry.
So
Make sure I get it in the right place myself. The 26300 minus 350 squared over 5 square root of the whole thing.
And that answers the question.
And that will give you a number. All right, that will give you a number.
Right.
If you actually do the calculation, I have another calculation too. If you want to, if you have it in your notes already from what we did earlier, you can tell me what the numerator was and what this part of the denominator. The only thing you have to calculate is this part. Right? We've already calculated the numerator, we already calculated the denominator there for the slope. Sum of squares for x.
Okay.
Right?
Yep.
So what was the numerator previously? It was something like, I want to say 330 over 170.
Oh, hold on.
Is that right?
Is it 160?
I was about to say, is it the 160 over 330.8?
Yeah.
I can figure it out. I can do it.
What was again? 160
160 over 30.
over 3 what?
30.8. No, 30. 30.8.
Yeah.
Okay.
Right? That is 2/3 of the numbers you need here. Right? Because that number is the same numerator as it was before. And this is the same sum of squares for x that we calculated before. Right? Now we just need to calculate this value, which is the sum of squares for y. So the 350 squared is going to be 12250. 1800. Right? So 1,800 times 30. 30.8. Take the square root of it. Don't forget to take the square root of it. Denominator.
I get 235.46.
So 235.46 divided into 160.
Divided by 160. 1.47.
No, you did it the other way.
Yes, I did. I just put it into.
And I know you did it the other way because you can't have a number higher than 1.
Ooh, that's not no. Like, look, I got that wrong. Wait a minute.
Oh my
0.67. Well, 0.68. Rounding off.
Yes.
Most of you are probably already aware because you've had this over and over again in most of your other classes. For example, a couple of you in my social class, we did this early correlation coefficients. Every correlation coefficient must return a value between -1 and 1.
Because this is what tells you, like,
How strongly they're related.
Okay.
A 0.68 with only 5 data points
Very.
is really strong, right? Has very, very high predictive power. If it were something close to 0, like a 0.068, right, there'd be no real correlation between them because so close to 0 is going to be meaningless. That Makes sense?
Yeah, you can have a negative, correct?
Oh yes, if you have a negative, where must the negative occur in the equation, given you've got a radical sign in the denominator? It must show up in the numerator.
Okay.
If you have a negative in this equation, you can have a negative correlation coefficient. It must, by definition, show up in the numerator of the equation. Because it can't show up in the denominator, because the denominator, first of all, is taking the square root, which is not going to have a negative number for this class, and, more importantly, the denominator is two positive numbers, two positive sum of squares times each other. Two positive numbers will always yield a positive product. Does that make sense?
Yep.
Correlation coefficients must always come in between -1 and 1. If you have a positive correlation coefficient, that means low values in your original data match up with low values on the other paired term, and high values pair with high values. So this indicates that the higher the number of hours you study, the higher your grade on the test will be. Conversely, the lower number of hours you study, the lower your grade on the test will be.
It's so funny because it's like, how do you study when you don't know it? Right?
Yeah.
You start with the things you know and bootstrap
That's
it right up.
right.
If you have a negative correlation coefficient, that indicates an inverse relationship, like say for example, I don't have the numbers here, but as an example, the more times you shoot up heroin during the week, the lower your GPA will be, the lower your grade on the
How
test
so
will
you better
be.
take your little ass in A.
Yup.
As
Well,
one
yeah,
seven
you're right, we'll go to detox.
with a negative correlation, as one set of numbers goes up, inversely, the other set of numbers comes down,
Okay.
right? Very important here. This creates predictive power. You can, in fact, right, generate a slope from a correlation coefficient. Mathematically, you can swap these equations back and forth. We're not going to do it in this class, but you can actually mathematically calculate one from the other, right? If I knew, for example, the slope predicting y and I knew the slope predicting x, I can use the two slope terms to calculate a correlation coefficient, right? Because they're both embedded in that same equation. Okay. Correlation coefficients must be between -1 and +1. Where closer to 0 means no real relationship. Closer to either -1 or +1 indicates a stronger relationship, and it also indicates higher predictive power. Right? Does that make sense?
I'm just gonna need to practice.
Okay, well, give you some practice.
See, I'm the type of person that the downloads sometimes don't start until a little bit later, like the hindsight, the learning.
Oh, you know what? I think I left the homework down in the office. I'll go get it real quick.
Darn.
Oh, we got 15 minutes. We're good.
Yeah, go ahead, take time.
Let me double check, make sure I don't run down there for no reason.
Let's do it out.
No gross.
Good exercise, go ahead.
Is that okay for correlation coefficients?
Yeah.
Yes.
I'm not gonna lie. You know, I never lie. For some reason at the bottom, when I'm trying to figure out this math myself, I keep on getting like a negative number.
Without looking at the exact number you have in front of you, I could not tell you why.
Right. Okay. Can you see this?
Why are you getting a
I'm
negative
just trying to
number?
figure out why we don't multiply
Because we do
that before we square it.
267,
Multiply
or
which?
226.
You're multiplying these two terms
Okay,
together.
hold on.
Yeah,
Hold
we're
on,
not
okay, now what'd you say?
I was trying to figure out why we don't multiply it before we square it.
There's no squaring involved here.
Yeah, multiply.
You multiply together, then take the square root. Because you have essentially standard deviation units here, standard deviation units here. So essentially you're squaring the standard deviation units. You take the square root to bring it back down to the right range for z-scores.
That's what I'm saying. Why would I get something
If you
different?
multiply them together first and then try to do the square root, you get completely wrong.
Yeah,
What do you mean?
should. If you multiply it and take the square root, it'll give you a number, but then if you take the square root of 30.8 and then the square root of 1800 and then multiply it, so it'll give you a different number.
Right, that's because the square root and multiplication are not reciprocal in that way.
What's the number, the one it's after the 233 down, okay, go some more.
squared by 5?
That one.
26300,
300.
which comes from right here.
That's where my
Okay.
answer is.
I thought it said 7.
Yep, me too.
26300 comes from right here.
Uh-huh.
Summation of y squared.
See, he thought it was a 9, she thought it was something else, so we both like.
If you ever
everybody
can't read my
doesn't
numbers on the
agree.
board, ask me,
Yeah,
and clarify.
hey, I gotta sit up closer.
Only your 4s and your 9s. I struggle with them.
I write,
It's
I
not
write
bad.
quick squiggles.
Okay.
And that 0 and 8
Oh, I see.
Yeah,
So
you got
my
an exam
answer
coming up in
probably
2 weeks,
all-
keep me critical. No, I'm kidding.
See, that's why I'm glad I went back and did the math myself, cause I would've got home and wouldn't have known nothing, unless I would've looked back at the, but I probably
We'll
wouldn't.
make another couple points here. And then I'll just get home. There are more than one way to calculate correlation coefficients.
Yes.
Right? This is the most commonly used correlation coefficient in the area of psychology.
Okay.
Right, the Pearson product moment. Another somewhat common correlation coefficient is the Spearman rank order correlation coefficient. Right? There's another one called a point by serial correlation coefficient. Right? And there's another one that's very similar to the point by serial. The different correlation coefficients all effectively work the same way. They take 2 sets of data, they try to mathematically calculate the degree of association between them. Any value returned from any correlation coefficient equation falls between -1 up to 0 up through +1. Right? And they're interpreted the same way in terms of higher one, the more direct the relationship is, closer to -1, the more inverse your relationship is. So you're essentially going from -1 up to 0 up to +1. All correlation coefficients will do. And in this case, the 0.68 is going to fall somewhere in this area, right? So it's a strong positive correlation coefficient. The difference between the different calculations for correlation coefficients is each of them assumes a different scale of measurement in them, or each of them assumes a different scale of measurement from their starting point. Okay? For example, if you're going to do a Pearson product moment, I say scales of measurement. What are the scales of measurement?
Like mean, median,
No. Scales of measurement. In the first week of class.
Nominal, ordinal,
Oh, okay.
interval,
And ratio.
ratio.
Correct.
Gotcha.
Right? Pearson product moment correlation coefficient assumes at least interval data. So if you're going to calculate an R, you have to have at least interval or ratio data. Right? If you only have ordinal data, right, that's where the Spearman rank order comes in. It's actually called the Spearman rank order correlation coefficient. If you have ordinal data, you can calculate a correlation coefficient on first, second, third compared to first, second, third. So if you have, let's say, a horse race, you run the horses and they all come in a certain order, first through eighth or whatever is the race. You take the same horses, run them again. They're not going to come in the exact same order, right? But they'll come in close. First place horse is likely to come in either first or second again. Right? And the last place horse is likely to come in last again. Right? There'll be a little bit of variability in the middle of the race, right? But there'll still be a strong positive correlation coefficient between those numbers. The 1s correlate with the 1s, the 8s correlate with the 8s, right? Make sense? If you're doing something like a point by serial correlation coefficient, that does correlation coefficients for nominal data. So regardless of your scale of measurement, you can actually do correlations on them. The vast majority of research in area psychology is going to use a Pearson product, but you may rarely see a Spearman rank order. Spearman rank order will be represented by the Greek letter rho. It's actually always spelled out rho. So actually using the Greek letter, they spell it out rho that way. What? Oh, okay. Does that make sense?
It does.
All right. In the interest of time, we are not going to do Spearman rank order. It's a relatively simple equation. It's a fun equation, but we don't really have time to do it this week's run time today. It works the same way in terms of correlation. I want you to recognize all correlation coefficients work and are interpreted the same way. Don't leave yet. I'm going to go down my office. I can home.
Okay.
Right, question?
Yes, sir.
Here's the problem.
I'll ask next week. You know,
Okay.
be prepared to come in and teach slowly.
What's your time frame on that?
What-
I mean, like, as far as how long are you gonna stay here? I mean, probably like an hour or two? Okay, because I'm gonna try to stop by.
That's fine. I expect we'll probably be here at least an hour, probably. Two.
Okay, gotcha.
we start at 1,
At least I might come just grab my schoolwork. Is that okay with you?
I would have to leave probably no later than 6.
That's plenty of time. We are not spending 5 hours.
That's dedication,
I know,
Dr.
right?
Reed.
I'm not spending.
I've got stuff later that night.
Yes, you're a dedicated man.
I'll be back in a second.
Y'all probably not. I'll probably be here, so.
Oh my.
Is anybody else just feeling a tad bit of suicidal?
No, not at all.
Oh, well, that's good. Me neither.
Yes,
Just checking in.
yeah.
Girl,
Just,
I be
it's
worried
okay.
about you.
You should be. No. Not to that extreme, but I'm like, when is the last day?
Hey, did you take introductions to substance?
Oh, that's been over.
Did you take introductions to substance use?
Which one was it? It's gonna be okay. For real. You can't tell me that you don't understand this a little bit.
I do.
Okay,
I understand it a little bit.
And if you keep telling yourself that you don't get it and you're not gonna get it and whatever, then you're never gonna get it.
Great.
You just have to.
Roll with the punches. Like, I feel like he like beat my ass though. Lord, forgive me.
But
Oh, you don't have anything on this. Oh, well, you're gonna do like, what are you gonna do? Something
Are you coming Tuesday?
You're not gonna do
No,
like.
I live really
I
far.
call
Far,
or anything.
No.
I don't blame you. I don't blame you. Where do you?
What happened to Litchfield?
Litchfield? Dang, that is
Yeah,
far.
I think that'll be good.